Okay, so let's look at our responses for this. Now, remember, and I know that mathematic just calls it the general form, but when we say general form, or they say general form, what do they mean? Standard. That's the standard, okay? So, we use standard, I prefer that term, but you can call it general. Now, I do want to point out, looking around the room, so we have a little bit of differing opinions. So like over here, I have x squared and 8x and 12. But most other people do not include the x squared and the x. Were we supposed to?
No.
Why not?
Because we're looking for the specific point instead of, I don't know, I just know that.
Okay, so let's talk about two things. So you'll have a lot of the right ideas, but first off, x squared is x squared. What is a? The value is 1, but like what is a and what are b in respect to the variables? There's a c word for those. Not constants. C is a constant. Non-corresponding, what did you say, Trent? Conjunction.
Quadratic.
What?
Coefficient?
That's the coefficients.
Oh.
Okay. So, you don't have to know that term. To me, it helps. The coefficient is just a value multiplied by a variable. And so when we look at this, I guess I should have been more clear about this in the past. A, B, and C are coefficients. Technically, C is a special coefficient called a constant, but A, B, and C are coefficients. Okay? And so, should we include variables when we talk about A, B, and C?
No.
No. Okay, so please be attentive to that detail, okay? That's why I'm bringing up this language. A, B, and C are coefficients. Coefficients are the values multiplied by a variable. Now, over here, Carter, you were thinking A is 0 in both of these.
I know it's 1 now.
Okay, so why is it 1?
Because it's 1.
It's understood 1. Remember, literally, like, if it was 0x squared, what would I have right here? Oh, I didn't have anything. That's the idea of 0, right? The fact that I have an x squared, how many x squareds do we have? 1. So A equals 1. B equals 8. C equals 12. B, A is equal to 1. B equals -10. C? Okay. What about A here?
2.
2, 7,
3.
and 3. Please note, do I have any variables with any of those numbers?
No.
Not any at all, okay? So A, B, and C are coefficients. If you weren't aware of that term and comfortable with that detail originally, I would highly recommend on that mathematic activity, I might write down that A, B, and C are coefficients. Those are just numbers multiplied by the variable, not variables. That would require us to get our sheet out. We should have mathematic out so that we can work through this. So let's get that out. I would, again, highlight that vocabulary if we were unfamiliar with that term. And with hole punches. Juan, you taking notes?
Yeah.
You writing any of this information down?
Yeah, right now.
Carter. Juan, that's not the right sheet. Yeah, the right sheet. Mathematic activity. It says quadratic formula. No, it's a mathematic activity.
Oh, what we writing on?
I am out.
Of course,
I'll have to order something. Hey, does anybody have a pencil for Sinai to borrow until I can get one? Mari has one.
I need a pencil.
What did you say?
You said,
Sorry.
Marty, Hank?
Him.
Miss Kenny.
I'm allergic to orange stuff right now.
For real?
Okay.
Oh, there you go.
Elwin, do you not have this sheet? Come on, we should have been at it out. Most people are done taking notes. Come on, just so you know, part of the active collaboration is also during the whole.
Let me get a paper.
Did you look in your notebook for it?
Did I tell you I didn't have my notebook?
You want some active collaboration.
Hey, I mean.
I'm collaborating.
Sometimes I need reminders, I got lots of students in class. Okay. Huh? Alright, so once again, when we say A, B, and C, we are only talking about the coefficients. I'll come back to that in a second. So, we did not actually get into the quadratic formula today. We're going to finish the quadratic, we're going to do the quadratic formula completely today and do one more concept or task, and it'll be the last method to solve a quadratic. Now remember, we had already learned 2. If we convert to factored form, what property can we use? Zero product property. If we convert to vertex form, what property can we use? Or what can we do? Inverses with properties of equality. Remember, zero product property is just the factored form when we got a product of 0. If you got vertex form, you can use inverses with properties of equality. Quadratic formula is the second or the third option, and we're going to learn one more today. And do you have to know how to do all 4 options? No, you only have to do 3. You got to be able to do 3. Okay, so you pick which one you don't want to do, but you pick 3. Alright, so we did all 3 of these yesterday. We took the time to go through the factoring. So this is the front side. So please go ahead and look at the front side quickly. Let me know, did we work through some of these at least yesterday? Okay, so we didn't get to C. Okay, so A, was it factored into X?
We did.
I know. But if I remember correctly, I'm not showing the work to get there, but we did the factoring to get x plus 6 times x plus 2. And then what do I do from here as a reminder?
Do x plus 6.
Not yet. X plus 6 equals 0. What did I just do here? What property did I supply?
Zero product.
I apply the zero product property. Guys, the only way to get a product of 0, one of what? One of the factors has to equal 0. Now, do I only set x plus 6 equal to 0?
No, x plus 2.
X plus 6 and x plus 2 equals 0, okay? And so then we solve those equations. Again, I am skipping some steps because you should already have this worked out. Okay, so that's not anything new.
How you make that good?
Say again.
How you make that good?
Well, remember, I'm solving this equation. What do I do to solve for x?
Oh, do the opposite.
So, I subtract, right? I use the inverse.
Oh, yeah, minus 6.
Right, so x equals -6. Same thing here. Right, remember, once you get down to seeing your variable only once, use your inverses and properties of equality. That's a big thing to notice. Alright, B here. I believe when we factored it, we found x minus 12 and x plus 2. Did we put minus 2? You got plus 2? Because I will point out, Carter, if you're putting this in the area model to factor it, it's got to be x squared, it's got to be -24, and then I need something that multiplies to give me -24 and adds to be -10. -12 and a +2. Is that, you good with that?
Yeah, I wrote down.
Okay. So yeah, -12x plus 2x. Okay, and so we got x equals 12 and x equals -2. And then we got to here. Now, this is where you really have to remember. So you said we did do this one yesterday?
No.
Started last minute, okay. So remember this, 2x squared, top left, right? That's where the ax squared always goes. What goes always in the bottom right? C. And if I'm looking at just that 3, which is what most people try to do, they look just at that 3 and they say, hey, there's no factors of 3 that add up to 7. And guess what? That is true. I don't need factors of 3. What factors do I need? I need factors not of 7. They add up to 7, but I need what? Remember, it's not just the C, it's A times C. 2 times 3 is 6. Are there factors of, yes, factors of 6. So, if you notice, see how I did 1 times negative 24? Because that's A times C. But when, hold on one second, when A is 1, you don't have to worry about it. It's when A is not 1 that you do, okay? Yes, Armani.
So when you can't find a factor on the own, we're doing the area for the AC method?
Actually, the AC method is technically what you always use. That's what I was pointing out right here. Notice in this case where A is 1 times negative 24 is just negative 24. So you don't have to worry about the A when A is 1. Because it doesn't change anything, okay? If you can't find factors of A times C that add up to B, that means you cannot factor and you gotta use a different technique. So if you cannot find factors of A times C that add up to B, you gotta use something else. And we'll look at some cases like that. So I have an activity that I've used for a long time now, after today, where I actually give you, I think it's 16 different equations. You don't have to solve them all, but you just sort them into what would be the best method. So you're thinking through what method would work with this, right? So thinking through, hey, do I have factors of A times C that add up to B? Can I find H easily? Because I will point out, actually I'll get to that later. Okay, sorry. Coming here, right, remember you factor. What do 6x and 3 have in common? A 3, right? Remember, does anyone remember how I taught you to use the calculator if you can't find the greatest common factor?
Didn't you get the number and divide it by what you're trying to?
So you're thinking of how I actually took this number and found factors? I'm talking about finding the greatest common factor right here.
No, I forgot.
Okay, how about everybody grab a calculator just to make sure we're clear on this. And Kinley, you can talk us through
Oh,
it.
yeah.
Okay. Alright. I was not alright.
Miss Skinny, I remember.
Good. That's one of the reasons why I love these calculators. Greatest common divisor is the same thing as greatest common factor. Okay, so remember, what's the button that lets me do cool crap? Video, okay? And what are we dealing with? Are we dealing with numbers or algebra? We're dealing with numbers, at least for the factoring side. And a greatest common factor is the same as a greatest common divisor. You won't be able to put in the variable, but I can put 6. Remember the bottom left-hand corner, down here under pi is a comma and 3. You just put those two numbers in. So 6, comma 3. What's your cousin condition?
I was thinking about it the other day, but I forgot.
Huh?
Can you like do all the steps again?
It's literally 3.
Hey, Bev, what's the button that lets me do cool crap? Okay. And what branch of math are we looking at right now?
Okay.
Numbers. And the greatest common factor is also known as a greatest common divisor. That's all it is. And then you just have to make sure you find the comma that is below the pi, and then you hit enter. That's it. The calculator will tell you what your greatest common divisor or greatest common factor is. Take advantage of that. Okay.
We ever had to use the least common?
Least common multiple, not with factoring. Because we're literally factoring, so we're finding the greatest common factor. Alright. If you need help with that later, let me know as I'm going around. There we go, to small groups. Okay, so what do 6x and 3 have in common?
6,
A 3. What do 2x squared and 6x have in common?
10.
They both have an x. Do they have any numbers? They also have a 2. Remember, use your calculator, the greatest common divisor. I can divide both of those by 2. What do 1x and 3 have?
1.
A 1. Okay, so my factored form is x plus 3 times 2x plus 1 equals 0. speeding through this so we can get to the second part of this. And so there's the roots or the zeros. So notice I just use my zero products property. Set each factor equal to 0. That's all, what we're doing. All the stuff on this front. A, B, and C on the full line. Okay?
Would you tell me what you do, instead of like time one, how would you do by two?
That's fine. As long as you divide by 2. As long as it's mathematically equivalent and it's good mathematics, I'm good. There are things I recommend. Like, I don't remember if it was Kinley or somebody else, but someone, I know there's teachers teach other ways to factor. It's totally fine. Miss Williams, she and I were talking. I thought she used the area model to factor. She just uses what's called, which is essentially the same thing, just without the area. So she does it like this, and then you have to find your greatest common factor like this. I found that students understand that area model better though, than saying, oh, these both have an x plus 3, and factoring that out, and I'm left with 2x plus 1. Same exact thing. There's multiple methods. So, as long as you can factor and solve it, I'm good. And as long as it's good math. Alright, that's the factoring side though, okay? We did not get to number 2 yesterday, is that correct?
No.
Okay. So, factoring again, you have a fair model to check your understanding, to practice factoring and solving quadratics. I want you to notice something. How different are A, B, and C in number 2 in comparison to number 1?
They're not
They're not what?
different.
They're not different. They're actually the same exact equations, but what we're going to do in number 2 is solve it by a different method. Now, I highly doubt that we remember this detail because it's not something I emphasized. Completing the square is a traditional method of solving a quadratic. However, what I realized was completing the square essentially just gives you the vertex form. So rather than teaching you a whole new strategy, whenever you hear a teacher talk about completing the square or abbreviates it, CTS, just think convert to what? To vertex form. The reason why it's called completing the square is because you literally get x minus h what? Squared. When you complete the square, you are creating what's called a perfect square trinomial. Rather than memorizing a new technique, we're just going to convert to vertex form. Okay? So what I want you to do with your small group at this moment is I'm going to give you 8 minutes, let's say 7 minutes, 7 minutes to get as far as you can with A, B, and C, but we've already done it via factoring. What method are we going to use this time?
Vertex.
We're going to convert to vertex form. So I need you to practice with your small group solving 2A, 2B, 2C by converting to vertex form. Alright, let's get after it. We'll come back together and talk about it at 2:12. Yes, ma'am. If you don't have a square, what do you not have?
Quadratic.
You don't have a quadratic, right? So if there's no square there, you don't even have a quadratic, and we don't want that to happen. But the whole point of converting to this was so that we can now solve it. So guys, like, I'm going to let you do B and C, but how would I solve at this point?
You would want to get rid of the, well, the one.
I would say,
I would do,
Get rid of the one, get rid of
so
the.
be careful, because, hey guys, I need to, so hold on. Kamai was saying that I would think about distributing, but here's the thing to remember. What's the point of vertex form? What can I do? If you have vertex form, you want to use inverses. You don't want to simplify, you want to get rid of stuff. So, Kia, why did you say plus 4 here? Where am I adding 4? To the what? see why you're thinking that, but it's not actually to the 0 at least first. I need y'all to remember, it's to the -4, okay? Carter, can I borrow that marker real quick? Actually, I got one. Why is it to the -4 first? Yeah, remember, the priority is I want this x here. The priority is not the 0, the priority is I want that thing. Well, if I add 4, what's -4 plus 4?
0.
And it's because of that Kia that I have to add 4 to the other side. The order actually matters. It may seem like semantics, but it's actually important that I'm trying to get to this. So I'm undoing things over here. When you don't pay attention to that, you get lost. Now, yeah, but do I, notice that's already a 1. Do I even have to worry about that 1?
No, you don't gotta worry about
I don't have to worry about the 1, okay? The whole point is to make 0s and 1s. It was already a 1.
it.
Okay, so now, what do I need to do?
Square root.
Square
Get rid of the
root.
Square.
Undoes that square. Notice again, I square rooted the square first.
Now you have to square root 4.
Ah, beautiful. I'm so glad you remembered that that's a +2 and a,
-2.
and what does that +2 equal? X plus 4. And the -2 equals?
X plus 4.
All right, last step.
So we did our.
That's still.
What? Subtract 4.
-2 and
Which one y'all saw, the first one?
-6.
Hey, do those solutions look familiar?
Potentially.
Potentially? Why would it what?
That's the first one?
I haven't gotten that.
Where would you have divided?
Like I'm saying, instead of minus,
I don't have
why would you do like?
What does division
Okay,
undo?
you're right.
Yeah.
That's the first
And
one?
so really, that's the first one, yep.
I think you did.
I'll come and look at your work in a second. What? Say that one more time? Ah, I got you. Well, because I'm following the math. So remember, the priority was that when I squared, I got a positive. But, like if I put a -2 in, what's -2 plus 4? What's -2 plus 4?
2.
2. +2. And what's +2 squared? 4, right? Remember, that's what we said we needed, was that 4. Notice if I put a -6 in, what's -6 plus 4? And what's -2 squared? It is also going to be not -4, +4. Remember, the whole idea was that x plus 4 squared is 4. And so it's not whether the x is positive or negative, it's what's inside of the square that's positive or negative. So it just, I followed the math that was there. Who said what? I will be there in 1 second. One final thing I do want to remind you of is, what I showed you yesterday that can help you here is, when using your inverses, what's the first thing happening to that x?
Go ahead.
Added.
It's being added by
4.
4, okay? What's the second thing happening to that x? It's x plus 4, and then it is
Square.
squared. And what's the third thing happening? Because does multiplying by 1 even matter?
No.
No, so don't worry about that.
We
What's
need to
the,
subtract.
Subtracted by 4.
and what was the first thing we undid?
4.
The subtraction by 4. What's the next thing that we undid? Yeah, the square. And then the last thing was that -4. So remember to pay attention to the order that you're solving this in. Okay? That took a little bit longer than I planned. I will come around and help groups. I'm going to give you all 5 minutes to definitely get through B and hopefully get through C. Just remember, we're also trying to solve. So really quickly before I go check on others, Queens, don't forget the whole idea was that this is actually equal to 0. We didn't even have a function. It was equal to 0 in the beginning. Does that make sense?
What?
All right.
What?
If it's square 49, don't square 49. Why is square 49?
I didn't know.
You mean square root?
Yeah.
Oh, you said square.
No.
You said 49 squared. Very different things.
Sorry.
Okay, so let me see what you got on money.
Okay, I did, we did it right. Well, I knew it, I wasn't thinking.
You just forgot it.
To
Yeah.
continue, like after this.
Yeah. That's where you.
Oh, wait.
Hey, hold on to it. Okay. They got -7/4 just like you did. It's okay. Stay calm. So let's talk about B really quickly. We're gonna go through this one, and I'm gonna go through C and talk about some details with C. So B, I'm not gonna spend as long as last time. With B, we should have gotten x minus 5 squared. Was it -49?
Yeah.
Okay? So remember, and this is what I was talking about with the what you doing? That looked a little sketchy. You better be careful. I don't see anything. So B right here. Oh, what I was going to say is, and this is what I was talking about with Bev, is you've got to remember when we have our standard form, we have ax squared plus bx plus c. But when I want vertex form, I need h and I need k. We saw this in the Desmos activity, but at the end of the day, you're just going to have to memorize that h equals the opposite of b divided by 2a. You've got to know that, and then you also have to know that an input of h gives you an output of k. Right, Duan?
Yeah.
Okay, so an input of h gives you an output of k. If you know those two things, you can convert to vertex form every single time.
Right.
All right. From there, it's just a matter of knowing which order to apply your inverses. And again, you don't have to, but I do recommend it. What's the first thing happening to x? Subtracting 5. What's happening after that? Squaring. And what's happening after that? Okay. That tells me the order to undo stuff. It's not the only way, but it sure is pretty easy. There's other valid mathematical ways to do it. You could do what's called a difference of squares here. But I just wouldn't recommend it, okay?
I'm confused.
Then, now I take care of my square.
Which one you confused on?
Now, we've got to be careful and remember, x minus 5 equals what? 7. And x minus 5 equals, when you take a square root, you got to have 2 roots. Alright. Sounds like a phone. There's no way a student at Hillcrest High School, a student in my class, has a cell phone.
How dare you?
So.
How dare you?
Okay. So, by the way, were those the same roots as before?
Yes.
Yes. Second of all, keep this in mind. If you have the solutions, so that you can check yourself, the solutions should make the equation true. Okay? Now, right here, I want to talk about C before we move on. So, the Queens had this done a while ago. I would go out on a limb and say, if y'all as a group are stuck, you want to go talk to Layla and Kinley, I would encourage that because they seem to get through even the fraction part of this pretty quickly. But yeah, it's a little weird because we do get the opposite of 7 divided by 2 times 2, so negative 7/4. So here's what I want to point out. Were we able to factor this one earlier? Yeah, we factored this one in 1c. So if I were you and I got to this point where I got a fraction for h, I'm going to stop trying to use vertex form and I'm going to use the factoring method. There are some times that factoring is better than vertex, okay? And there's other, but the reality is vertex form will always work, just sometimes you can get a fraction. And then for those of us who freaked out, yes, when you, so this is my value for h. For the value for k, you just have to be careful typing it in. And you get negative 25 divided by 8. Well, that's our k, right? So, where's all of my erasers?
Oh, I got you, Coach.
Okay. All right. So I'm going to erase this. Okay. So 0 equals 2 times x plus 7/4 squared minus 25 divided by 8. At this point, it is vertex form. I'm still going to use inverses and properties of equality. It's just got fractions, right? But the fractions actually aren't bad, and I'll show you why in this case in just a second. So, what's the first thing happening to x, by the way? Add 7/4. What's the second thing? It's being squared. What's the third thing? Times 2. What's the fourth thing? Okay. So what's the first thing I need to undo? I need to add that 25 divided by 8. Okay? Notice I'm undoing these. Alright. Kamai, I think it was you that asked me earlier, is it okay if I just divide instead of multiply? Was that right? This equation is a perfect example of why I recommend using the reciprocal. Because if you divide by 2 right here, Now you got a fraction within a fraction. That's not as easy to work with, but what's another way to divide by 2? Multiply by 2 divided by 1? What's 2 times 2? 4. So I don't think it's 2 divided by 1. 1 divided by 2. Because notice, what's 1 times 25? 25.
Oh, so you got a fraction, so you do it? Or
I would, yeah. I highly recommend it. And what's 2 times 8?
15.
Now, again, this right here is why I said earlier, am I, Mr. Kinney, using vertex form or factoring here? I'm factoring. But this can still work out because now I take care of my square by doing the square root. And Layla, I showed you this earlier, like, yeah, you can take square root of 25 divided by 16 in your calculator, but what else can you do here? Yeah, what squared gives me 25? 5. So you know what the square root of 25 is? 5. And what's square root of 16?
4.
So once again, am I recommending that, I'm going to pull it over to here,
I got a
just so I
question.
can leave that up there. Hold on one second, just because I'm almost done, then I'll answer your question while some people take notes. What I will point out here is this. I don't think I've shown y'all this notation yet, but this is personally what I do in solving equations. You can write it as 2 different equations, but that literally just says positive, negative 5/4. So, what you would do is I need to subtract that 7/4. 7/4 minus 7/4, 0, sweet. And then I just do positive 5/4 minus 7/4. And I do negative 5/4 minus 7/4. So instead of writing 2 different equations, that gives me negative 12 divided by 4, which is negative 3. Hey, are those the roots we got earlier?
Wait,
Sure, I guess.
What's negative 5 minus 7?
I thought you gotta turn it to the opposite. I'm confused.
Remember, I did a positive and negative 5/4. So instead of writing 2 different equations, you can 100% go ahead and do that. I just write it like this, and I subtract 7/4 from that positive and negative 5/4. I got you. Fine, just hold on 1 second. So, if you wanted to, you could do a positive 5/4 equals x plus 7/4, and negative 5/4 equals x plus 7/4.
Okay.
I personally like to just go ahead and write as 1 equation to be lazy,
Okay.
but it's mathematically equivalent. If you don't like that, then don't do it. This is 100% valid.
I ain't understand.
Okay, Kamai, what was your question?
What's 2 times 1/2?
Over here?
Yeah.
So let me go back and remind you, from the beginning, I personally would never have used vertex form here because we got a fraction, okay? But if you do choose to use vertex form, remember that's the same thing as 1 divided by 2. It's also called the reciprocal. So 2 is understood to be divided by 1. So I multiply by its reciprocal of 1/2, and that creates a 1.
Okay, so why did you go for the 2 first instead of the...
Can you say that one more time?
Why did you take care of the 2 first before you took care of the square?
So remember, when I read the equation up here, it's x plus 7/4 first. X plus 7/4 is being squared. So even though the 2's in front, we're squaring before we multiply. And then we subtracted 25/8. So remember, you work backwards. So I took care of the minus 25/8. Then I took care of the times 2. Then I took care of the square. Then I took care of the plus
So
7/4.
you're doing PEMDAS backwards? Okay.
So remember, PEMDAS is actually the order of operations to simplify. But what am I using? I'm using inverses. So I'm undoing all of that, and I've got to undo it in reverse order. It's not the only way, but if I'm using inverses, that's typically what I want to do. Okay? I'm going to give you a couple minutes to write this down, and then we're going to get to numbers 3 and 4. So get down whatever information. By the way, don't forget, do you have to use vertex form on 2C? No. Would I, Mr. Kenny, do it? No. I would factor it for sure. There's factors of A times C that add up to B. That's what I'm doing. Yeah, but 3 is going to be applied into... Actually, this is still 3 down here. What's that? What's your question? I don't know. I guess we'll find out.
I know I did it, just I forgot.
Yes, sir.
We already did that.
Duane, you got all those notes?
Hey, Devon, you got the papers.
What y'all debating? Okay, I'm gonna leave C over there. Looks like most of us that have engaged throughout this have down what we need. What's up, Kamari?
I engaged.
You didn't get what?
I engaged.
You did?
I need to.
Oh, wait, is it?
Do you understand the math better?
I love you too. I love you.
No. See, that's what that's trusting Mr. Kenny. That's what that looks like, is doing the things, engaging like that. All right. So let's look at number 3. Apparently I forgot to put the actual slide 3 in there. Okay, so in the beginning of 3, we took the time to identify A, B, and C. By the way, did y'all notice that 3A, 3B, and 3C were the same as 1A, 1B, and 1C? And 2A, 2B, and 2C? They're all the same.
What?
Equation. Look at 1A, 1B, and 1C. Nope, on the other side. Oh, sorry. Those are the same exact equations. That's what we just had.
He is.
They sure are, right? So do we know what the roots or the solutions ought to be? Yeah, what the roots or the equation or the solution should be?
The same.
They should be the same. Here, I think we got -6 and -2. And so when we solve it this way, we should get -6 and -2. Now, the quadratic formula. This is probably one of the most famous formulas. You remember the Pythagorean theorem that you learned in middle school and then you used in geometry? A squared plus B squared equals C squared? You remember that thing? Pythagorean theorem? I hope. Okay, quadratic formula may be, not saying it is, but it may be even more famous than the Pythagorean theorem, okay? It is one of those formulas that you're going to have to learn. And I may actually do something that Ms. Granberry did with her kids, where her kids had to get it signed off by 3 different teachers, and they perfectly said the quadratic formula to them. So like just saying it out loud, you got to know it. You got to memorize it. So I think I'm going to give you all that assignment tomorrow, so that by like Wednesday next week, you've taken time to memorize it, and you can say it out loud to another teacher.
I don't think I do that. Could you do it?
I'm going to have a small assignment where you have to memorize this and then say it out loud to 3 different teachers and have them sign off saying that you actually said it correctly.
Can I do this?
Yeah, sure. Actually, he might not be here next week, I'm not sure. Okay, but you have to do it 3 different teachers. Alright. Huh?
What is
It
this
does
for?
not have to be math teachers. Because you're going to give them a slip that has it written out, and then you have to say it out loud. Alright, but let's break this down. Let's try not to destroy my boxes. Thanks. So, what is this formula right here called?
Quadratic formula.
Quadratic formula, right? So now I know you have Miss Williams, she does a little song with it. Second block asked me, hey Mr. Kenny, do you do the song? And I responded, I'm scared to sing in my own car, so the answer is no. But I will show you all the song on YouTube. I'll show it to you on YouTube. So, I also will say this, there's part of the song that I don't love mathematically, because how would you read this statement right here? Negative b. So pause right there. Negative b, please hear me, implies that it's always going to be what? Negative. It does. But that's not negative b. Just like with the h equals, what's another way to say this?
The opposite.
The opposite of b, which is not what the song says. The song starts out with negative b, blah, 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 I don't know. But if you do it as the opposite of b, huh?
She said opposite of B.
Did she do it? So she rewrote it. Good. I'm glad she says opposite of b. Anyways, that says the opposite of b. Plus or minus what?
Square root.
Square root of
B squared minus 4.
b squared minus 4ac,
All over 2.
all divided by 2a. Okay? That's the other part I don't like. I don't like the all over. It's not mathematically accurate. Anyways, that's an aside. So, Kenny was asking me earlier, hey Mr. Kenny, is it supposed to be the opposite inside of here? No. Does it say opposite?
No.
Don't make it the opposite unless it says it. Okay, so here we said A equals 1, B equals 8, C equals 12. So what's going to go right here? 8. That's B. And then 8 as well. And then 1. And then 1. Guys, that's it. That one. Yep, that's the song. If you like learning stuff to music,
Hey, those are kind of hard.
apparently that's going to be our money's go-to. After she picks up my scissors. Alright, so go ahead and stop at our money. Okay, so once you have everything substituted in, all you have to do is what? Now simplify, okay? Now, everybody needs a calculator in hand to practice this, but I do want to point this out. What should we simplify first? Because I always get the question, hey Mr. Kenny, can I type the whole thing in? And the answer is no and don't.
Wait, what should we simplify?
Yeah, so I will agree the numerator, but is there anything beyond just saying the numerator, anything specific?
Multiply first, right? 8.
What are you going to multiply?
2 times 1.
The 8.
You could do 2 times 1 separately, but personally, so I would actually go ahead and do the 2 times 1 for sure in the denominator. But what I'm looking at is this. Okay? Now, instead of being vague and just saying this, there's actually a name for that thing that's underneath the square root. Okay?
What's in the parentheses, like negative 4 times 1?
This is called, hold on, a radicand.
Okay, I never.
Okay? I'm going to write that larger so everyone can see it. The word radicand just means what is underneath the radical. That's a radicand. Okay? So I'm going to use that proper term just because it's actually easier. Instead of just saying this, it's the radicand. It's what's underneath the square root. Okay?
I was about to ask, can you show us what the radical was? That's what I was about to ask.
Oh, the root symbol is called a radical.
Oh, I forgot about that.
The root symbol is called a radical. Yep. Actually, even easier than that. Just type that on the radical. Hold on. The radical, the square root is a radical. So like this little thing here, this symbol, L1 is the radical. You can have a fourth root. This is still called the radical. So that symbol is called a radical.
Hey, what you wrote, like,
So that's what I'm saying. Like legitimately, hey guys, hear me clearly on this. Alright? My job is to teach you Algebra 2. I don't care about you knowing how to square stuff and multiply stuff and add and subtract in the right order. What I care about is that you can simplify this correctly and get the right roots. Just type the radicand into the calculator. Not the radical. Do not put the radical in there. Just type the radicand into your calculator. Pick up a calculator, type in just the radicand. Miss Armani. What?
That's what I did.
Oh, man.
Sure.
To the office, I run there.
Wait, what I'm saying?
Oh my god.
But can I show you this real quick?
Oh my
So
god.
you're not wrong.
Oh my
Right,
god.
like, that's what I'm saying. Just put in your radicand
Hold on.
on one fell swoop.
Oh, I got you.
Doesn't, but like, isn't that easier? Just,
Wait.
well, that's what we're gonna get into, okay? Just type in the radicand. 8 squared minus 4 times 1 times 12.
Alright.
Thank you, Kenley. I'm aware it's 16. Well, you still don't get to leave until the bell rings.
Keep going.
So, our money. Turn it off. Play it on your own time. Alright, so, please understand, the simplest thing to do is just type your radicand into the calculator. Don't make it harder than that. Now, you can just automatically do the square root, but we're going to learn tomorrow why I don't want you to put the square root in right away. Okay? So, just type in the radicand.
Oh, that.
I'm hungry, bit, bro.
Oh, is it because of the
Oh, I
square?
put the
thing?
top. Oh, you did the second one.
Ooga booga. What's up, Martin?
I'm
Alright,
in a commercial.
okay.
Both got a commercial.
What's the, hey guys, what's the square root of 16?
Hey.
Who
I'm
else did it?
hungry.
Commercial?
Hey, Bev, you in the math?
Yeah.
Okay, so what's the square root of 16? 4, thank you.
I did too.
Now, notice that that's just plus or minus 4. Hey, what's negative 8 plus 4?
-4.
Negative 4. And so I have negative 4 divided by 2. What's negative 8 minus 4? Negative 8 minus 4.
Hold on, wait.
Negative 12.
Yay!
Alright,
Hold on. Say something I like and stuff at you.
so what's negative 4 divided by 2?
Hello?
Negative 2. And negative 12 divided by 2. Hey, do those solutions look familiar?
I am.
Are those the same ones we got in 1A and 2A?
You mean those right there?
What
Those
is
right
this?
there.
It's easy. I ain't gonna lie.
Oh, you lost me. No cap.
Kia, where did I lose you?
You mean those
You lost
negative
me
2
with
and
the 4 and
positive
the 12.
So, you understand that the square root of 16 is 4, right?
Right.
Okay, so what I have is negative 8 plus or minus 4. So what's negative 8 plus 4?
Okay, got you.
What's negative 8 minus 4?
Oh, I didn't see that minus.
You just do it as 2, once you get there, you just put it into 2 different expressions.
Can you have a commercial?
What can I expect?
Oh my gosh, you're being humble.
Okay.
No way, man. I'll take it.
Alright.
Can you solve me?
Do you want to do it on your own?
Let's not.
Alright, I'm going to give you 3 minutes to substitute in and solve B on your own.
I just did. Hold up, cause I just did on the
Look!
Thank you.
What's your A again? Oh yeah, A is
That's what I'm working on.
You mean that vertical service right?
I thought you were going to
Huh? Oh.
be gauging.
Not you did.
And my stats kids already have a lot of my calculators though. But if you're at home and you're trying to do these calculations, y'all have used Desmos as the classroom thing. But hey guys, I need you attentive to this so that you can learn. If you just go to Desmos and you go to Open Graphing Calculator, you can type in all that stuff right here. If you click on the keyboard in the top bottom left, it gives you any operation you can need, even functions you've never heard of. Okay? So like, if I do 10, was it negative 10 earlier? Squared minus 4 times 1 times negative 24. There's that 196 we got. Okay? So Desmos will do these calculations for you. right? If you come down to the next line,
minus
square root of 196, there it is, 14. So, hey guys, if you need to do calculations at home, Desmos has got you covered. Also, fun fact, guys, or specifically Ellen, Desmos is allowed on, or is given to you on the ACT. So, if you do the digital version of ACT, so it's good to practice with it. You're right. All right. Let's do some quick notes. That was you. All right, quick notes. I need y'all to attend to this very closely. If ax squared plus bx plus c equals 0. Guys, I need y'all to hear me very clearly. The quadratic formula does, okay, I've got people not attending to these details. If your quadratic equation does not equal 0, then you cannot use the quadratic formula. The quadratic equation has to equal 0. So if this is true, then x equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. What is this whole thing called?
You good?
Quadratic formula.
You good, kid?
You got them up? Yeah.
What?
Oh, whoa.
Cologne.
Okay.
Sorry, sir.
If you want it broken down into steps, I'll give you some steps here. But it is much easier if you just understand that equation. Your steps should be though, like if I want to use this formula, what's the first thing I need to figure out?
What you say, Carl?
Even before that, what is B? So what is A? So what is A, B, and C? You gotta be able to answer that question first. Okay? Once you know what A, B, and C are, what did y'all do with that equation? Plug it in. Or a more mathematical term for that is substitute.
The one in front of the mirror. Cause you blew it. That's the one.
A, B, and. Sorry, that's the symbol
okay.
and.
No, that's mine.
What time is it?
All it is, I found around this.
It's, we still got 2 minutes left to get these quick notes, okay? What do we do after we substitute our values in? Okay, so overall, all you really have to do is simplify, but I, Mr. Kinney, recommend simplify what part of the radical?
How?
So the radicand.
Your radicand.
Take your square root and then finish simplifying. The big idea is, guys, substitute A, B, C in and simplify. That's really it. But you need to know what A, B, and C are. Huh?
Where are you? Once again.
My bad,
I will point out, hey guys,
Right
right here, there's some check your understanding questions at the end of the mathematic activity. How could you check your answers at the end? Could you substitute your numbers back in and see if it makes the equation true? Hey guys, I will also, hey pause for a second, I will also remind you, if you were to graph the quadratic function, those roots should be the same as your what?
X and Y.
Not x and y. Your roots should be the same as your x
Value.
intercepts. Guys, if you take the time to graph your function, Your roots should be the same as your x-intercepts. Take advantage of this. Here.
Something said yes.
Good, keep that.
Alright. Hey, Trent, what is that giant Kit Kat wrapper on my desk?